Got a 9-volt battery here, and if I hook it up to my multimeter here to measure the voltage, you can see it's about 9.6 volts. But let's say that I need a higher voltage than that for some reason. Well, I could hook up a second 9-volt battery in series, and that would give me a higher voltage. But let's say I want a higher voltage, but I don't want to use a second battery. Is there some way to do that? Well, here's a 1 microfarad capacitor, and if I put the capacitor across the battery like this, it'll charge up the capacitor. And so now this capacitor is charged with 9 volts. If I put this in series, just like I put the other 9-volt battery in series with the first 9-volt battery, I get a higher voltage, almost 18 volts. Of course, as the capacitor discharges, the voltage is going to drop. And I can move the capacitor back, charge it up again, then put it in series, and the voltage will jump up again. But of course, again, it's going to drop. And when I take the capacitor out of the circuit to recharge it, the voltage also drops because I'm breaking the circuit when I take the capacitor out. So what I want is a way to somehow keep recharging the capacitor and putting it in series with the battery, but also keep the output from dropping to zero. Well, what I can do is add another capacitor across the output here, like this. That way, when I take the first capacitor and I put it in series, not only does it produce an output voltage here, but it also charges the second capacitor. So now when I remove the first capacitor, you can see the voltage doesn't actually drop to zero. And that gives me some time to charge the capacitor, put it back in series, the voltage will jump up. I can go ahead and then charge the capacitor again. The voltage doesn't drop to zero. Put it back in, the voltage jumps up again. And so now what I need is just to find a way to move the capacitor back and forth faster. Well, here's something I came up with that'll help make that easier. I've got a capacitor connected to a switch like this. And when the switch is in one position, the capacitor, both legs of the capacitor are connected to the blue wires. And if I flip the switch to the other position, both legs of the capacitor are connected to the green wires. And so if I put this in the circuit here, I can connect the blue wires across the battery, and I can connect the green wires in series with the circuit. That way, when the switch is flipped in one direction, the capacitor is charging through the blue wires. And if I flip the switch to the other position, the capacitor is now in series with the circuit, and the voltage jumps up. I switch it out of the circuit, it charges. Switch it back in, the voltage jumps up. Switch it out, charge it, put it in the circuit. Charge it, put it in the circuit. And you see, as I switch this faster and faster,